Hello, welcome to this video. Today we're going to look at this functional problem. So we want to find all functions from the real numbers to the real numbers that satisfy f of x squared plus y from z is equal to x times f of x plus z times f of y for all x, y, and z that are real numbers. So we don't have any restrictions on x, y, and z, such that this will be satisfied. So with these functional problems, you want to the first thing you want to do is substitute in a couple values for x, y, and z. Try to play around with this and try to find certain rules that the function has to obey for all values that are for all numbers, for all real numbers. So the first thing that at least I saw to do was maybe because we have this thing where y and z only appear as y f of z and z f of y. Maybe if we set y and z both to 0, we can get a restriction only on x that perhaps would be useful. So what I'm going to do is x stays x, and this is not a regular equal sign. This basically says I'm defining it to be this way. I'm defining x to stay x, and seriously, I'll define y and z to be 0. It's not something that I got out of a chain of logical statements that got me to that point. So I'm saying I'll define x as x, y as 0, and z as 0. And what I'll get, what I will get is y times f of z is 0 times f of 0, which is 0. And same thing with z f of y. So both of these would be 0, and we'll get that what is left is f of x squared is x times f of x. So it's like we can pull the x out of the x squared in front of the f. Now from this rule I want to establish another rule. So first of all, this rule will be useful to us, so I'll put it here in the corner. F of x squared is equal to x f of x. So that's going to stay there. Next, I want to see, because now I want to get a relationship between f of x and f of negative x, which, because that's always useful with functions, because when you're maybe substituting in negative values or subtracting off of things, it's good to have a relationship between f of x and negative f of x, and f of negative x, if you can get one. And so, because x squared and negative x all squared is the same, because negative 1 squared is 1, if I take this rule and substitute in that x is negative x, I get that f of x squared stays the same. So that's f of negative x squared, but which so we'll see it just stays the same, yeah. And this is equal to, well, negative x times f of negative x, and this obviously stays the same as f of x squared. Now f of x squared, we've already established, it is equal to x times f of x, and so we get that x times f of x is equal to negative x f negative x. And you can see, and this is true for all x. So what I can say, well, if x is not 0, then if x is not 0, then I can say that now I can remove the x's, I can divide by x from each side and get f of x is equal to negative f of negative x, which is a very useful relationship. You don't have anything complicated going on. It's just you take out the minus, and it's more useful written this way, because if you have f negative x, you can just take the negative out. Now we can say, well, it doesn't have to be x is different than 0, because if we look specifically x is equal to 0, we can see if we substitute in x equals 0 here, we get f of 0 is 0 times f of 0, and so f of 0 is 0. Meaning that, yes, f of 0 is negative f of negative 0. So let me just write that down, substituting in x is equal to 0 here. We get f of 0 is 0. And so it does work that negative f of 0 is f of negative 0. Because negative 0 is 0. And so this is just 0. F of 0 is 0. Negative f of 0 is also 0. And so it also does apply to x is not 0. And so, quickly erase this. And what we will get is that this rule is actually true for all x. So for x is equal to 0, privately it also does work. And so our second rule is f of negative x is negative f of x. Okay, now that we've played around for a bit with x, we'll now soon try to play around with z and y, because all we did we got both of these rules just by the substitutions of z and y are 0. We didn't do anything useful with them other than just saying what if they're not in there. So let's erase the board and then look at what we can do with y and z. Okay, now let's look at what we can do with y and z. So this time I'll let y and z stay the same and let x equal to 0. So I will get, if I define x as 0, y stays the same, and z also stays the same, we get x is equal to 0, and so we'll get on the left hand side f of y, f of z is equal to z f of y, because this is also 0 when x is equal to 0. So this is the relationship we got. So doing f on y f of z switches the y and the z, sort of. So this can actually be useful to get what is f of something. And so now if we, let's say here, if now we say y is equal to 1, for this we get that f of z is z times f of 1, and f of 1 is essentially a constant. So f of z is just our same z, just times a certain constant. And now and so now that we have this established, this is also be useful as one of our rules. So I'll replace z with x just to be consistent with these rules. So f of x is equal to x f of 1. Now, what I want to do is, because you can see we did get a rule of x times f of x, and it's just f of x squared. And this y f of z and z f of y looks very similar to x f of x. If we just let z and y both be a certain value, the same value, we might be able to get a certain another restriction based off this rule. And so if I now define y is equal to, let's say, a, and z equal to that same a, we get f of a. It stays the same. It's a f of a. Now, like I said, by our first rule that we've established, we'll get a f of a is f of a squared. So we get f of a squared is equal to f of a squared. But now, what is f of something? Well, it's that something times the constant f of 1. And so this is actually equal to, we'll get a squared f of 1. And so f of a certain real number squared is that same number squared times f of 1. This will be the rule that will let us solve this problem. So now let's write it here too. And again, I'll replace a with x to be consistent with these three rules. So f of x squared is x squared times f of 1. Now, let's erase all of this, and we'll look how we can now find f from these rules. Okay, now we're ready to look to find f of x based off of these 4 rules. Actually, we'll be using like I think 2 or 3 of them, because we used the other rules to get the new rules that will help us find f of x. And so, let's see, what is f of x? Well, I'm going to split here. I'm going to split it for the case where x is bigger than or equal to 0. Because if x is bigger than or equal to 0, we know the square root of x is also a real number. And so we'll be able to say, if we plug into here as square root of x, we'll get f of x is x f of 1. And so, let me erase this. We'll get that we can substitute in square root of x into this rule, and we'll get f of x is the same as f of square root of x squared, which is square root of x squared times f of 1, which is x times f of 1. And that is if x is bigger than or equal to 0. Now we need to see what if x is smaller than 0. Well, if x is smaller than 0, we've already established that f of x is negative f of negative x, like this rule says. Just multiply by negative 1, we'll get that. And so, this is negative f of negative x. But now if this is the case where x is negative, and so if x is smaller than 0, negative x is bigger than 0. And so, we'll be able to say that now f of negative x is negative x times f of 1, as we saw in the case where x is bigger than or equal to 0. So this is negative of negative x f of 1, because we substituted in here negative x. And now these negatives cancel out, and we get x is x times f of 1. And so in both cases, it's x times f of 1. And so we get that it is equal to x times f of 1. Is that the end? No. We need to check that it actually does work with these. And if it doesn't always work, we need to find what f of 1 needs to be for it to work. So now let's erase this, and we'll see if it always applies, and if it doesn't, what f of 1 actually needs to be for it to apply. So f of x is x times f of 1. Now let's see, substitute it in here. So f of x squared plus y f of z. So we'll get that on the left hand side. Is x squared plus y f of z multiplied by f of 1, which f of z is also z times f of 1. And so this is x squared times f of 1 plus y times z times, well, it's f of 1 from this f, but then we're multiplying again by the f of 1 from the f that was on the entire thing. And so this is times f of 1 squared. That's the left-hand side. And that needs to be equal to this. Now, f of x is x times f of 1. F of y is y times f of 1. And so we'll get that the right-hand side is x squared times f of 1. From f of x is x times f of 1. And so this x times f of 1. X squared times f of 1 plus z times f of y is y times f of 1. So z times y times f of 1. And these need to be equal. And so these need to be equal. So let's write this. We'll get x squared times f of 1 plus y z f of 1 squared times here is equal to x squared times f of 1 plus yz, I just switch the product here, times f of 1. And so we need this to be true for all x, y, and z that are real numbers. So first of all, these cancel out because they're just the same thing, x squared times f of 1. Now because we want this to be true for all y and z, we'll be able to say that we can divide by y and z, because if we just pick something like y and z are both 1, then we can divide by it. And it's the same thing, so we won't get anything that doesn't work. So we'll be able to also cancel out y times z, and we are left with f of 1 squared is equal to f of 1. And so we figured out two things. One, it doesn't always work. Two, f of 1 needs to satisfy this. Now this obviously works. One, if f of 1 is obviously 0, so either f of 1 is 0, or if it's not 0, that means we can divide by it on both sides, and we'll get f of 1 is 1. And so these are both of our options, and so we just substitute them in back into f of x, and we'll get that f of x either is 0 times x, which is 0, or f of x is x times 1, which is x. And this should apply from what we just did. This should work with the original. And you could just substitute them both in and see that it works. 0 obviously works because both of these would be 0. X also will pretty much obviously work, because then we'll get x squared plus y times z here is the same as x squared plus y times z here. And so both of these work. And so, based on all of what we did, based on all those rules we have established, and based on this to find out what f of 1 has to be for this to work, and you can easily check that these do work. These are the only solutions for this functional problem. And finally, that's it. If you want more content like this, please subscribe to my channel. I'll be uploading more interesting problems and things like this in the future. And finally, that's it.